We will explore end behavior of a rational function when oblique asymptote is there. So the question before us is behavior of a function near oblique asymptote. Function given to us is f of x equals to x squared plus 2x minus 1 divided by x minus 1. Now, since the degree of numerator is 1 higher, we expect a oblique asymptote, right? So we can write since degree of numerator is 1 higher than denominator, we expect an oblique asymptote. So first we need to know how to calculate this oblique asymptote. We could do it by dividing numerator by the denominator. Okay, so you could do synthetic division or long division. Since many of my students are not very familiar with synthetic division, I'll go for long division. So let's divide x squared plus 2x minus 1 by x minus 1. What do we get? So taking the two terms, multiply by x, that gives us x squared minus x. When you take away, we get 3x minus 1, and we could do plus 3 times. So we have 3x minus 3, 3 minus 1, and when you take away, you get plus 2 here. So plus 2 means the remainder is positive, and now we can write this function f of x as equal to, we have a quotient x plus 3, right? X plus 3 plus the remainder, which is 2, divided by the divisor x minus 1. So clearly we have an oblique asymptote whose equation is x plus 3. The function is going to approach this line. However, there will be a distance between it since we have plus something 2 over x minus 1. Howsoever small that may be, there will be a separation, correct? So let me kind of sketch this line, and then we'll see how to decide about the behavior. Okay, so what we will do here is sketch the graph of the line x plus 3. Slope is 1, y-intercept is 3. So let's say that is the graph of the line. Okay, and the line here which I am sketching is x plus 3. So that's the oblique asymptote. Now to find the behavior, let's consider when x is positively large. If x is a large value, positively large value, you could actually substitute 1000 here and just check. Then what do we have? We have this quantity is positive, right? This quantity is positive. Positive means f of x is x plus 3 something, right? So that means you could think like f of x is equals to x plus 3 plus something, right? Let me call that delta, right? Maybe very small, but something. And that clearly, since it is positive, we are approaching from above. So in that case, since this part, the remainder part, is positive, so we are approaching from above, right? The reason is that this portion, x plus 3 plus remainder part, is positive, right? Now let us consider the second case when x is approaching negative infinity. You could substitute minus 1000. In that case, what? In that case, let me rewrite this. F of x equals to x plus 3 plus 2 over x minus 1. So if I substitute a negative value here, then this portion becomes negative. That means lesser than x plus 3, right? So lesser than, that means less than. So f of x is less than x plus 3, right? Now since f of x is less than x plus 3, so it is approaching from below, right? So approaching from below, right? So in that case, here it is approaching kind of like this. Do you see that? So that is what we are talking about as far as the behavior of the function is concerned near the asymptotes, correct? Now if you want to really sketch it, you could do so. There is one vertical asymptote at 1, let's say, right? So I'm not giving you details, but I like you to sketch the function, and then you could find x and y intercepts and then sketch this function and get the result. So what you'll see here is that the function kind of will look like, let me take another pen. Once you find x and y intercepts, I took it very close. It'll be kind of like this. Yeah, that is how the function is going to look. However, you need to find the x and y intercepts to get accurately this particular graph. I hope the concept is clear. We'll take up another example, and then I hope all the things will be perfectly in place. Feel free to write your comments, share your thoughts and my videos, and if you like, that'd be great. Thank you and all the best.